Other is your horizontal deflection plates. So these two deflection plates, they work in synchronization to trace meaningful pattern on the screen. How does it work? That is very important, very interesting. And from how does it work from that point of view? um, there is the two mode of operation, as I discussed in the last turn. One is YT mode, where the voltage, time varying voltage signal, or rather time varying periodic voltage signal, is traced against the time. Your y axis is the voltage axis and x axis is the time axis. That about that we are most familiar. It means about this mode of operation we are most familiar. But there is another mode of operation where we trace one time varying voltage signal with respect to another time varying voltage signal. One of the signal is applied across the x plates, y plates, and another is x plate, and we get certain pattern on the screen. That those patterns are called Lysage's patterns, and with the help of these Lysage's pattern, we can make many measurements. Many applications are there. So we'll discuss both of them from the application point of view. But now here we are talking about the construction and working of the oscilloscope. So as far as the this diagram is concerned, the vertical plate feed is will remain same whether it is working in x mode or yt mode or xy mode. It will remain same, but there is a major change in um, the connection to the horizontal plates when as far as these blocks are concerned. In this case, um, these blocks are valid for the YT mode of operation. In the case of XY mode, here this time-based generator and trigger circuit is not there. They are disconnected. Rather, it will remain these trigger circuit and time-based generator. They are the integral internal part of the oscilloscope. It will remain over there. But when you will select the XY mode, then horizontal amplifier is disconnected from the time-based generator, and then whatever signal you will give one of the channels, that will be fed to the X plates. So in XY mode of operation, both the X plates and Y plates are fed by the external time variable voltage signals, and one of the these two signals are plotted against each other, and we get certain kind of pattern. These patterns are called deciduous pattern, and by using these deciduous patterns we can make many measurements that we'll discuss in detail. So right now I'm discussing these. So up to this point I had already explained on the next turn, last turn. If anybody is having any query regarding it, you can ask, please. Anyway, I'm moving ahead. Here, this is a very important thing. I want that most of you should be present. I don't know how many of you are present. uh, very few are present. Anyway, we cannot. So this is very interesting and very important phenomena. That means how does your oscilloscope works in YT mode. So in this case, actually, um, when signal is given, suppose a sinusoidal signal is given to the X plates only. When there is no signal on the X and Y plates, obviously the electron beam will go to the screen, and it will strike the screen, and you will get the point is there. Means a display, it will display a point where it is hitting the screen. That point will glow. Now suppose I'm asking to you that if we are applying, there is no connection to the horizontal plates. If we are applying the sinusoidal signal to the Y plates, then what kind of trace will we get on the screen? जी, अगर हम साइनोसॉइडल वेवफॉर्म यहाँ अप्लाई कर रहे हैं तो what kind of trace will we get at the screen? There is no voltage signal connected to the X plates or horizontal plates. जी, कुछ फरमाएंगे आप लोग? I'm asking very simple thing. This is your screen that is in one of the view of your CRT. Okay, and there are Y plates, and then there is electron beam. If we are applying a sinusoidal waveform across the Y plates, then what kind of trace will we get here on the screen?
Sir, luminous white glow.
जी बताइए, हाँ सही बताइए, क्या कह रहे हैं?
Sir, luminous white glow.
नहीं, glow is fine, but what kind of glow? Whether it will be a circle or a straight line or some other pattern will we get? Well, it is very common sense if when we are applying this voltage. So obviously for this part, if we are applying like this, so or rather the
Sir, oval or elliptical.
any basis for your answer? Like this, if we are applying. So in this part, you can see that this will be at the higher potential. This plate will be higher potential than this plate. So obviously, your electron will get attracted towards this, and in this part, it will negative polarity, so it will be deflected downwards. Your your electron beam. So here we will have a straight line, vertical straight line like this, and every time it is retraced, like this. It means in this case it will go up. From here it will go up, and for negative part it will come down. For zero part it will come back here, and then it will go down for negative part. Then again for next cycle, it will come back to zero, and then it will go up and come down. So it will keep on retracing the same straight line. So we'll get a vertical straight line on the screen. Is it fine to all of you?
Yes, sir.
Okay, because there is no horizontal um, uh, deflection, so it will only deflect vertically up and down. So we'll get the straight line. Even this primitive straight line trace is also having certain measurement information. How much will be the length of it? Can you tell? How much will be the length of it, this straight line? It will be equal to
Maximum amplitude of the sinusoidal waves.
not maximum, but the peak to peak.
Yes.
Peak to peak voltage. So you can see that how important is this device. Even it is not working perfectly, even then it is giving the information about the signal. Now I'm coming back to our main objective, but our main objective is to trace this varying voltage. we want to trace this varying voltage. So what is the requirement for tracing this varying voltage, time varying voltage, which is varying in sinusoidal form? So it is a periodic time varying voltage signal, and we want to make means to trace it on the screen stably and faithfully. Faithfully means without any distortion. We want to make a want to trace it. Then what else we require as far as the movement of the electron beam on the screen is concerned? What else we require? If we draw, if our hand is an electron beam, if we draw a sinusoidal waveform, then what we do as far as the movement is concerned? What we do? I am tracing it. What we do? What I am doing? Yes, please. I am moving my hand in y direction simultaneously in the x direction also. Is it fine? I am moving my hand up and down as well as
Yes.
horizontal direction. Is it fine?
Yes.
Same kind of movement we need for the electron beam also, that it should move up and down as per the magnitude of the signal which we want to trace, and then simultaneously we want to move our hand in the horizontal direction. So for the horizontal deflection, we are having a horizontal electrostatic system which comprises two plates. Then obviously for the deflection of signal across the horizontal, in the horizontal direction, for the deflection of the beam in the horizontal, we require certain voltage to be applied across the horizontal plates also. So what is the requirement? We want that when your trace, your electron beam is deflected in vertical direction as per the amplitude of the signal you want to trace, simultaneously you want that your electron beam should move horizontally across the screen at constant speed. At constant speed, if you are not maintaining the constant speed, so where your speed is less, it will become peaky. Where your speed is small, then it will become flat. More, it will become so. Although you will be able to um, trace a waveform, but it will not be the same waveform whatever you are applying at the Y plates, but it will be distorted waveform. So we want that the requirement for the faithful um, um, means for faithful and accurate trace without any distortion of a time varying waveform on the screen, we want that wide in the electron beam should deflect in y direction as per the amplitude of the signal which we want to trace. And as far as the horizontal deflection is concerned, it should be at the constant rate independent of your input signal. It should move, means as far as the speed is concerned, it should move from left to right at a constant speed, because if there is no signal, then we should get a straight line. We should get a straight line without any. So at a constant speed we should move this way, then should come back, then again go here, then again come back. Continuously it should keep on doing. So what kind of voltage will ensure such kind of horizontal movement? Yes, please. Across the X plate or horizontal plate, we require a voltage signal which ensure that electron beam should move across the screen horizontally repeatedly. again and again at constant speed. That is very important. At constant speed, the deflection of the electron beam horizontally should take place at the constant speed, at the constant. It is absolutely necessary. Otherwise, if there is a variation in the speed, then your signal, you will have the trace of the signal, but it will be distorted, not the faithful reproduction or tracing of the signal. So what kind of voltage signal will ensure this kind of movement of the electron beam horizontally? जी, कोई बताएगा भाई? It is basically this signal. We apply the voltage signal of this form. It is called sawtooth. I'm not able to draw it perfectly, but so this is called, basically this is called time based signal. It is called time time base signal. What it does, what it does, you forget about the X plate. We are not connecting anything on the X plate. And if only time based signal is connected, actually there is a time based signal generator in the transform, in the oscilloscope. This is an integral part of the oscilloscope. Every oscilloscope has a time based signal generator, and this is connected to the X plate only when you are selecting the YT mode of operation. YT mode of operation. So what will happen when this part is coming? You will see this part means the ideal signal is something like this. So you can see that this part is basically in this part, when this is applied across the plates, then your electron beam deflects from left to right, and when this at a particular rate, at a particular speed, constant speed, because this, you can see this is a straight line, voltage is, rate of the change of the voltage is constant, straight line is constant, then this part, obviously this part we can take like this part is having sharper slope, so it will come back at very fastly. It will come back here, then again it will go slowly from here to here, means in the next time base signal, then again it come back fastly here. Now if this signal which is applied to the Y plate and this signal which is applied to the X plates in YT mode of operation of oscilloscope, your electron beam will move like this. It will go. Now you can see that it is moving vertically as well as horizontally. So it will trace like this, and it will reach to then again it will come back very fastly here. So this trace is in this region, this part of your time base, and then it is coming back very fastly in this region. It comes back here, then again the next cycle it again traces. So same waveform is traced again and again, and then again it is coming back, then again. So we see this as a stable signal on the trace on the waveform. So are you able to understand that how does your oscilloscope works in YT mode to trace a voltage varying periodic signal on the screen, stable display? I'll come to the stable display. It is only for the trace of a periodic voltage signal, time varying periodic voltage signal on the screen. आप बताइए आपको समझ में आया कि नहीं है?
Yes, yes, yes.
देखिए अभी I'll discuss more these things here. You should concentrate on few things that uh, how you should have a feel that how these this your electron beam is like a pen, and these deflection plates are like your hand. So these deflection plates are holding the pen, and then and they are moving it, means in the x direction and in y direction, so that we can have a good, faithful, accurate, undistorted trace of a periodic waveform. For that purpose, for YT mode of operation, across the Y plates we apply the voltage, time varying periodic voltage signal across the Y plates, and across the X plate we apply time base. Time based signal is basically a sawtooth waveform, which is having one low, means one part is of low slope, and other part is of the very sharp slope, that is a return path. So these things I try to explain. Many more things I will discuss. I'm coming back to the. So this is how you can see that time-based generator is there. And one thing is the application of time-based generator across the Y plates, X plates, and the signal which we want to trace across the Y plates. Then synchronization of your time-based signal with the signal we want to display. It is very important for a stable display. You must have seen, those who have worked on the oscilloscope, when you want to see the sinusoidal waveform, trace the sinusoidal waveform, see the sinusoidal waveform on the screen. You applied certain channel, and then because you are not aware of many things on the knobs, screen, means the knobs of the oscilloscope. So you make here and there certain scales you change, then you can see that your trace is getting bigger and smaller, and it is not stable. Many time you'll find, most of the time you'll find it is not stable. It is running from one side to another side, or from another side to one side, or it is jumbled up, all jumbled up. So because we don't have proper knowledge of operation of the oscilloscope, that's why it is like that. Anyway, this this synchronization makes the difference. Means if your waveform which you want to see is not properly synchronized with the time based generator circuit, that is your sawtooth waveform, that is called time base, time base, that is called time base. It is not which is applied across the horizontal plates. When these two signals are not synchronized together, then you won't get the stable display on the screen, and always you'll face the difficulty. And why how can we do that? We'll discuss during operation. We'll discuss. So this is the block diagram of oscilloscope. When oscilloscope is working in YT mode, when it is, you will see there is a knob on the screen through which you can select whether you want to. I'm not able to show it here, but always you will have a knob through which you can select YT mode, or you can select XY mode. Uh, by default, it works in the XY mode, sorry, YT mode. But when we push that button, then it will start working in a XY mode. I'm not able to find out here, So there must be some. If you look in the laboratory oscilloscope, you will find it is XY. Then you can see that here this is a time per division scale. This basically changes the slope of your time base, and this is volt per division knob, which basically changes the gain of the this amplifier, this vertical amplifier. And time based generator, there is a some knob which basically changes the your time per division, the slope of the and then this trigger circuit synchronizes help in synchronizing the time based signal with the signal which you want to, periodic time varying signal which you want to see. How it does that we'll discuss. It is you can see that it is another um, way representation. uh, these are the is means not only we are, as I told you earlier also, we are having many more parts than these are the basic parts which we discuss. In oscilloscope we are having many more parts. Here you can see that these are the focusing anode. Means we want to make the beam sharper and should not spread. You can see that electron beam is thick here, but after this it is becoming a very sharp one, and there is a knob actually to focus it. So voltage across this is applied so that your electrons should get deflected from all the direction. That's why it is a cylindrical, hollow cylindrical. So it becomes thin, sharp, focused. So, and then we are having grid also to uh, to um, uh, to you can see that intensity of the means the number of electrons. If you want a very dark or very sharp, very dark, you can say um, glow, not dark glow, means bright glow. If you want, then obviously more and more electrons you have to allow. And if you want dull display, dull trace, then we capture electrons here in the grid. So this is also connected to the voltage, and accordingly it attracts the more and more electrons, and when it is less, then less. So this way, this is another part that you will find. Otherwise, major parts you can see y plates and x plates are there. Then this is a photograph. You can see that many parts which we have discussed, they are present here. You can look upon this is a typical CRT. Then we talk about these things we had already discussed. When electrons hit the screen, the phosphor is excited and emits the persistence, how long display glows. Oscilloscope is operated in two modes: YT mode, that is most common. We are familiar with all, though, so both of them are common. But as far as our because we are not very much exposed to the use of the oscilloscope, so we are more aware of the YT mode of our operation, where the periodic time varying signals are basically traced. Then there is XY mode also. Then what is the difference between these two operations that I had written? In YT mode operation, the time varying periodic signal is plotted against time. The voltage signal is applied on the Y plates. Means voltage signal means that signal which we want to trace. And if sinusoidal voltage is applied to the Y plates and X plates are not connected to any signal, so that's what I ask you. That's what I ask you. Here, what will be the resultant trace on the? So here I try to show you it is a straight line, and it is a straight vertical straight line. The same thing, whatever I explained. So these are the, for faithful display of sinusoidal varying signal, the electron beam should move vertically and horizontally simultaneously. That's what I said, by giving the example of a hand. If by hand we are tracing on the board or on the paper sinusoidal waveform, so we move our hand vertically as well as horizontally simultaneously. Vertical deflection is decided by the amplitude of the signal. This vertical deflection, you can see that it is representing the peak to peak voltage. So it is decided by the amplitude of the signal. The electron beam should reflect horizontally across the screen at constant rate. This constant speed, that's what I told you, that is, it is very important requirement. So then how can we ensure a constant constant movement of the electron beam horizontally across the screen, it is a time-based signal. This is a time-based signal that you can see it is a sawtooth waveform. So this part, which is having sharper slope, is called flyback. Means it works like that. It goes, your electron beam goes like this, and then it flies back very quickly, which may not be which may not be visible, because this flyback is very quick, very small. It may not be visible, but generally in oscilloscope, during flyback time, oscilloscope is having it basically blocks the electron. So flyback trace is not appearing. It blocks the electron beam, and then again when it is going, then again there is a electron beam, but again flies back. So you can see that the process will be, it will go here to here, then it will come back, and so it will trace again and again. So you will find that the trace is permanent, means it is stable, because every time new cycles comes and it goes this way. So this is how so this signal is called time-based signal, which is applied across the horizontal plates when we are our oscilloscope is working in the YT mode. So this is a typical time-based signal, sweep and then coming back, then sweep, then coming back, like that. So now I told you that um, for a faithful operation, for faithful trace of time varying periodic signal on the screen, it is very important that
Sir, can I
first
ask a
first
question?
essential thing is that your the signal which you want to periodic time varying periodic signal that you want to trace on the screen, it should be applied across the Y plates, and the time base should be applied across the X plate. Second thing is that both of them should be synchronized. Means this synchronization is very important part, and because of the desynchronization of these two, we could not see the display of the stable display of the waveform that generally we encounter. So that is because we are not able to synchronize. How can we synchronize, and what is the meaning of synchronization? That I'll discuss these things, although are operational parts, but they are very important. Even if you are not aware of the operational part, you may not be able to operate the oscilloscope properly. You will always face difficulty. So try to concentrate what exactly I'm trying to explain, because this is related to the operation also. So means meaning is that um, I'll discuss with these slides only. Time based. So first of all, we should have these two signals across the X plates and across the Y plates. Then synchronization of these two are very important. That I'll try to explain here. The time-based signal triggering must be synchronized with the periodic time-varying voltage signal for its stable and faithful display. The time-based signal should be initiated. This is very important. This is very important. What is the meaning of synchronization? This point in the red is basically the meaning of synchronization. The time-based signal should be initiated, triggered every time at the same instant within a cycle of periodic signal. This is what is the meaning of. Now I'll try to explain it. You see, this is the many thing. This diagram is having many things. I'll try to explain. This is a sinusoidally varying or time varying periodic signal which we want to display on the oscilloscope. सुन रहे हैं आप लोग भाई?
Yes, yes, yes.
Okay. Now this is your time base. This is your time base signal. Now for 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 stable display of this signal, we want that time-based signal should be triggered, should be initiated at the same instant within a cycle of your signal which you want to trace. What is the meaning? Means if this is your so this is your trace part and this is your flyback part. This is your trace part and this is your fly. So if this is the time based signal, this is your signal which is applied, which we want to trace. It is applied across the Y plate and this is applied across the X plates. So what will happen? Your electron beam will travel like this and it will come to this point. Then obviously this flyback is coming, so it will go back to again here. It will go back again here, and it will is like here. It will come here again, and it will again trace. Then it will go back again to the initial point, and then it will trace again. You are able to understood whatever I'm trying to explain or not? Here I had shown that it will go here to here, and then it will come back. Then again it will drop from the same, because again it next you can see same instant here. First time based signal is initiated here in the one cycle. Next time it is initiated here, and again. So although it is tracing again and again. So first, whatever the first thing which I want that you understand here, that is very important, that whatever part of your signal, your time base, this part of the time base signal covers, only that part will be displayed on the screen. So you can see that this part is covered from here to here. So this part will be visible on the screen, it will be traced, and then it will again come back here. This is one thing. Second thing is that if we are not ensuring that our time base is generated again, then it will be traced once and coming back, then everything is gone. Because means if you are not tracing your plot again and again on the screen, your oscilloscope is not having capability to show the traced in means indefinitely. So so again in the next cycle, at the same instant, this is very important, at the same instant your time base should initiated, should be triggered or should be initiated. Then again your glow means in the first cycle it is going this way and electron beam is coming back. Then again in the next cycle, when that time base is triggered on the same state again within a cycle, then it will again retrace it and it will come back here again after this. Then again next cycle you should trigger your time base at the same instant. So you will find same kind of waveform is traced again and again. So a stable display you will have on the screen. So are you able to understand this phenomena, this operation, how this time base is contributing in stable display of your time varying periodic signal? Two requirements are there. First of all, you should have a time based signal. Second, it should be initiated every time at the same instant within the cycle of the unknown signal, the signal which you want to trace, same instant. So this is the meaning of synchronization. And as I told you, only that part of the waveform will be traced, will be visible on the screen, which is covered by the sweep part of your base signal. Your time based signal is having two parts, sweep part and flyback part. So whatever part of the waveform is covered by the sweep signal, that will be displayed. And then this sweep, your time based signal should be initiated at the same time, at the same instant within a cycle of the suppose this is not happening, and you try to concentrate. If this is not happening, suppose one time first your Suppose um, uh, first time your time base is initiated here. Okay, next time your time base is initiated here. Suppose next time your time base initiated here. So what will happen? First of all, you will have a trace like this, then it will come back, then you will have a next trace from here, then third time you will have a trace from here to somewhere. So you will find it because successively your triggering is happening here, then here, then here. So you'll find that your signal is moving ahead, like right to left. If other it is other way around, your signal is triggered here, your time base, then it is triggered here, then it is triggered here. So plot will be moving like left to right. It is moving left to right. And if it is random, sometime here, sometime here, sometime here, sometime here, then it will be jumbled up. Your display will be jumbled. So are you able to understand this? What is the meaning of synchronization of your time base mm, with the signal, periodic signal? Ji, please. I have devoted a lot of time to make you understand. This is very important in operation of oscilloscope. Otherwise, we are having application and everything. That is easy to understand. Ji, anyway, now this is the we want that the time base should be properly synchronized with the um, unknown waveform which we want to periodic time varying waveform. And again, I'm very particular about the periodic time varying waveform. So if your signal is not periodic, your oscilloscope is not capable of showing the non-periodic time varying signal stably. Means running mode, obviously we cannot see. And nowadays we are having a digital uh, oscilloscope where frame of it can be captured and shown, but in running mode you cannot oscilloscope is not capable of showing the non-periodic time varying waveform. So here, because his phenomena is like that, if your signal is non-periodic, it is very difficult. Now how this synchronization is done, another question is how this synchronize. This is synchronization, whatever I explained, that every time your for faithful and stable display of the time varying voltage signal, we want that our time base should be initiated at the same time within a cycle of the waveform, periodic time varying waveform which we want to, at the same time it should be triggered. Only then you will see the stable. Otherwise, if it is triggering at the here and there, then your display will not be. How should we do that? So for that, this is called level triggering scheme. All the oscilloscope, whether it is a primitive analog oscilloscope or a nowadays you are having a digital oscilloscopes. Every oscilloscope has got this triggering scheme, although the many additions are there, but the level triggering scheme remains same. There are the in advanced oscilloscope there are the additions, but but the basic level triggering scheme will always be there. Extensions, rather, you can say, not addition, extensions are there. So what is level triggering scheme? Our main objective is that we want that our time based signal should be initiated at the same time within a cycle. So level triggering scheme, there is a DC signal level, there is a DC signal level, and this DC signal level is movable, it goes up and down. There is a knob on the, you see, um, level, you see this is a level. So this is the knob. As you will move this knob, then your DC level will go up and down. In digital signals, you will find a horizontal line, whatever I had shown here. When you will move that knob, then this DC signal level will appear for some time, then it goes disappears. So this is your periodic signal is basically compared with the DC level. Then you can see that this DC level for this periodic signal is crossing the signal twice in one cycle. Now we'll identify there is a positive and negative slope selection also there. So when we set a DC level like this, and then we selected the positive slope. So obviously whenever your signal will cross this level, then this instant will be identified and a triggering pulse will be released that will initiate the time based signal from the time based generator. Means your time based generator will operate and it will release one time based signal. Now in the next cycle at the same instant you see DC level is cutting your signal again. This will send a signal, triggering signal, and then again next time base. So this will ensure that every cycle at the same instant you are getting. And obviously if your signal is not periodic, then you won't be able to trigger time base properly, and so it will be difficult to see the stable signal, time varying signal on the trace of the. So that's why I'm repeatedly I'm saying that this is for the periodic time for the periodic signal only. Oscilloscope works, displays stably and faithfully. So this is level triggering scheme. It is called level triggering scheme. You can see that this is your DC level. This is a comparator. How does this scheme is basically implemented? So comparator, this is a variable DC supply. So you see your this is your signal. Suppose sinusoidal. This is your level. You can up and down it obviously. So in this case if you look, if you're since you are not aware, so we never know that our level DC level is within. Agar aapka DC level if it is beyond the signal, then obviously your triggering is not working and you will have all jumbled up. Means anytime it is basically at its own default rate. Your time based signal is initiated, and here it is having another frequency, so obviously you won't have display, proper display. So we have to keep within whether this side or this side. Means you have to make sure that the same time in the same direction your DC level cut the signal. If you are having a periodic signal like this, then obviously if it is within the range, your DC level is within the range, then it will make sure that this should happen. So this is how this is how your level triggering scheme works. And whenever it crosses signal crosses the selected or decided DC level, then it sends the triggering signal to time based circuit, time based generator. It generates the waveform. So this is how this is done. Now again you see I try to show you that if your sweep part is covering one cycle, it will show 1.5 cycle. Here you can see if it is covering 2 cycles, then it will show the 2 cycles, and so on. Like you see 2 cycles are there, time base here. So when we basically move the time per division knob, here, this is time per division knob, then we basically um change the slope of your sweep part. And the slope, so when slope is more, then obviously it will take less time to reach the peak value. And if slope is less, then so this basically your time per division knob varies the slope, and accordingly we see the part of which is covered by the sweep part. That part of the signal, it's traced on the, it's visible on the screen. So this is how triggering of the time base works. I try to show you. This is your triangular signal. This is your time base. This is your DC level, and then every time it basically crosses in a particular direction. You can choose this as well as this, so you get the, the triggering pulses, and then every time you have So this is whatever we have shown you earlier. Then other things, this is a trace on the oscilloscope, you can see. Then there is a big divisions. So whatever they say, one division per volt means vertical scale is one division per 1 volt per division, means this bigger division corresponds to 1 volt. So if our signal is going from here to here, so 1 2 3 4 5 6, so the peak to peak voltage is 6 volt, and then maximum voltage is half of the 6 volt, that will be 3 volt. Okay. Then similarly we are having, you see, one 1 volt means 1 volt per division, and this here 1 volt microsecond. So 1 microsecond per division is the horizontal scale, and means this one division correspond to the 1 microsecond. And now we take from peak to peak, or from this peak from to this peak will be one period. So this 1 2 3 4, so 4 microsecond is the time period, and 1 upon 4 microsecond will be your frequency. This is how things are done. So here you can see that this is, I think, is a triggering level. This is your base, something like that. So whatever I explained here, that is basically is done here. So 250 kilohertz is the frequency, and 6 volts peak to peak, and here you can see that this indicates the zero level. So this is not a simple sinusoidal wave. It is basically it is having a DC offset also. So its positive part is more, positive part is 4 volt, and negative part is, so it is having a DC offset also. And this is our triggering, and this T is showing. So this is a ground indicator. आप oscilloscope में, especially digital oscilloscope, you will find this. So this is how the trace is analyzed, you can say. Trace is analyzed, and if there is no DC, then obviously in between we will have this here. So we will have plus 3 volt, minus 3 volt in between. Then in more advanced oscilloscope, you will find all these things already, means you are not supposed to calculate everything, you'll get, it's a ready-made, everything you will get here. And then bandwidth is also an important part, but we'll discuss it on the next one. I'm closing today's discussion here. Okay. So we'll resume our discussion on the next one from here only.
Sir, syllabus for second session is
G,
18 से start. Sir, syllabus for second session 18 से start है.
when will it start?
Yes, sir.
It is starting from 18th, no?
Yes, yes.
Next week I'll tell you.
Okay.
Today is 7 4.